So we are Plastic Cracks Plus Plus. My name is Andrew Rivera.
I'm Caleb Moore.
I'm Joshua Chastain.
And Nathan Lupker. So a quick little overview of the project. Our client is Dr. Warner, a construction management professor at SIUE. So Plastic Cracks was a senior project back in 2015. Dr. Warner is also the client for that one. Originally, she mostly just wanted us to fix the original plastic cracks. So basically, plastic cracks is a calculator that determines when it's best to pour concrete based on the current weather. So we attempted to salvage the original project, but links to the weather service were broke, and some of the libraries already used were discontinued. So we decided to remake the original plastic cracks. We haven't decided on a framework or what language how we're gonna redo that yet, but we're leaning heavily towards using Django. We'll go into more detail about plastic cracks in the next slide. So as the semester progressed, we learned more about what Dr. Warner wanted this webpage for. So we decided to add a couple of calculators, including Bogue, TC Powers, and Mixed Design. Again, we'll go into more details about these. So this webpage will mostly be for students to use the calculators and learn, but also for industry workers wanting to use the plastic cracks calculator, or anyone who really wants to learn about cement. So basically, Plastic Cracks Plus Plus is a suite of calculators, graphs, and other visual aids for eager learners, and a tool that details the quality of weather for concrete pouring for industry workers and students.
So the Plastic Cracks implementation that we're doing is the exact same as the original one as far as this calculator goes. What it does is it takes several ambient weather metrics and calculates the evaporation rate, which helps to determine the chances of plastic crack shrinkage, which is what it really is fine cracks on the surface of the concrete before it actually sets, which is usually just a visual problem, but can also lead to some integrity problems over time that affects the long-term durability of the concrete. So in the bottom left here, we have a sample of the original, something similar to the original output of the original plastic cracks, which shows the risk level of these plastic shrinkage cracks occurring by day and each day's risk level. And then on the right has a small chart to kind of show the interaction between and the relation between these different ambient metrics that we use to calculate this rate of evaporation. I'll go more in detail about the plastic cracks implementation that we're using when we go over the prototype.
So the first calculator that Dr. Warner wanted us to add as additional function was the Bogue calculations. What these is a set of equations that help you determine what type of cement you get for using a particular ratio of ingredients. So on the top right of the slide, you can see that these are the equations that are called the Bogue equations. There is two different sets, which is determined by the amount of A or F, which if you look below is the alumina and the ferric oxide. So if the ratio is above a certain threshold, you would use case A or case B. Dr. Warner mentioned to us that of these ingredients, only 5 of them are necessary for our particular set of equations. So that would be the lime, silica, alumina, ferric oxide, and the sulfur trioxide. These will then create the compounds on the bottom table. And then from that, the ratios, you can determine what type it is. So that bottom right ratio you can see is 55% the first type, 18% the second, 10, 8, 6. That type is type 1, which is normal, but also called Portland cement. It is used primarily for just about everything. It's the common type of concrete, like in walls and pavement. Then there's more specialized types of concrete, such as for type 2 and 5, which need resistances to sulfite corrosion when places such as soil or water with high amounts of these compounds that cause corrosion. And then type 3 and 4 are used in situations where their benefits are needed, such as high early strength, or in types 4 case when you need a cement that does not produce a lot of heat while it is being set. And now we will have TC powders.
So the TC Powers calculations are from a scientist named TC Powers. He proposed a set of calculations that can be applied to all Portland cements. It used to be a lot more complicated until he proposed this. I think it was around 1960 maybe. I'm not sure. So all you need to solve these is the water cement ratio and the degree of hydration. And then you get your evaporable water, non-evaporable water, gel pores, hydration products, capillary pores, porosity, and gel space ratio. So we're going to show all that in our prototype, and then we also have a visual aid on the right there that we're gonna demonstrate. And then next we have mixed design.
Mixed design. The mixed design calculator will be used to determine the amount of concrete created based on the mixed design that is entered. This can be useful for contractors and students because they can enter different mixed designs and see the amount of concrete created along with other characteristics. The user will enter different amounts of cement, fly ash, slag, water, fine aggregates, and coarse aggregates. And then the bottom will populate the amount of concrete along with volume, mixed volume, and moisture content. And then next we'll demo our prototype.
For the landing page of the application, we decided to stay pretty much the same as the original Plastic Cracks application, which is just the ability to enter your zip code and get the Plastic Cracks calculation for that area. Now, similar to the original application, you don't need an account to use the calculator. You can use it without registering, and you'll still be able to see your calculations. You'll be able to save them to your device or share them with a link. But what you won't be able to do is save them to your account within the application. So for the output that you see here for the Plastic Cracks calculator, this is going to depend entirely on how specific the details from the weather service we can get are. If we're able to get it by the hour, or if we are not able to get that precise of information for all the metrics needed to calculate the evaporation rate used in the calculator, then we may have to switch to something a little bit more similar to the original implementation, which is to just go by the risk level for plastic shrinkage cracks by day and by month, and still also be able to see the metrics that go into that calculation. So like I said, this is going to depend entirely on the kind of information that we're going to be able to get from the weather service. This is also, you can of course, whenever you do log in, then you will be able to save the calculation to your account, which is not a page that we have set up on the prototype yet, but you would essentially just be able to save your calculations to view them later and maybe be able to compare them or take whatever deductions you need to from them. And you'll also be able to view your account page and change your password or log out. And next we'll talk about the Bogue calculator.
So as you can see, it's split up into 4 different parts here. The top right is a set of instructions for the calculator itself, sort of giving an outline of each of the boxes, the top left being the input, the bottom left being the output, and the bottom right will give you a preset output if you want to see an example of that type of cement output ratio. So if we now hit play, we can see the output example. So as we can see on the bottom left, we have the percentages in a row, but then on the top right, we get a nice graph of the results. So on the left hand would be the ratio of inputs in a graph form, whereas on the right hand side, we'll have a ratio graph of the outputs. This allows you to give a nice representation of how your inputs get turned into your outputs, how the different ratios affect your compounds created. So then on the bottom right, this now turns into more of a little quiz question, whereas before it was to select an example output. Now it's asking you what the results look like the most to you. So in this case, if we clicked 4, we would see that it says correct. This is a little bit of a placeholder. We'll have a little more information as to why it's correct. For example, Dr. Warner gave us ranges that each of the compounds percentages should fall within for a certain type. So when for correct, we would have it has say this falls within 3 of the 5 ranges, therefore it is the closest type. And if you want to show incorrect, so if we redo this calculation and then say picked 5, we would see that it's incorrect, and we would have a similar explanation later saying maybe something like it only hits one of the ranges out of the 5 potential outputs. So then also, one last thing is that we wanted to have it also compare one calculation to another calculation. So if we hit compare, it'll take those old results and put them into the left side of the graph. So now if we happen to put in a new thing, we would be able to get the new results and compare them. In this case, we'll go ahead and take a predetermined type, type 2, and as we can see, we'll have the output on the bottom left, have the percentages, and on the top right, we have the new bar graph, and we can see how our manual calculation compares to the average of those ranges for that type. So we can get a very good visual comparison. And so now that we're done with that, we'll go on to TC powers.
So for the TC powers, like I was saying earlier, so we just enter our water cement ratio and the degree of hydration. We press play. So then we get our output, the evaporable water, the volumes, porosity. The thing we're most interested about is the volumes on the right there. So we do want to have like a dynamic graph to kind of demonstrate what exactly is going on. And so if you click the back button, we would show like the change between the old one and the new one. So so we would store a couple of them on the client side, so so they would be able to see the difference between them and kind of really understand the concept. And next we have a mixed design.
So the mixed design calculator is pretty self-explanatory. The user will enter the amount of ingredients under the notation. They will enter the specific gravity for certain ingredients, and then answer a couple questions on what kind of test it is. And then they'll click play, and then the bottom will populate the volume of that cement mix that is created, along with moisture content, volume, and the mix volume. Next slide, please. And then next semester plans. For next semester, we will schedule sprints and update requirements. We will create flowcharts and diagrams that would show us the layout of the website. And then we would also test interaction of our website with fellow students. And then finally, we will test our Django framework, test our databases, and then test our code as well. And that's our presentation. Thank you.